You just drop in and just smack the lip. Whoop-ah! Drop down, snap. Ah!
So now, let's go to differentials of multivariable functions. If you have a function of x and y, say z, a specific change in x, say dx, and a specific change in y, say dy, then the total differential of z, denoted by dz or df, is just this function. So it's the partial with respect to x times dx plus the partial with respect to y times dy. And what happens is that, of course, whenever the values of my x and y changes, the value of z also changes correspondingly. And what dz does is it approximates that specific change in z given those specific changes in x and y, provided that x or dx and dy are very small. dz does not exactly give the actual change, but it gives a very good approximation, especially again when the change in my x and the change in my y are both very small. So let's try to apply this. For this example, I only want to find the total differential dz of this function. So my dx and my dy are not specified. So I just need to find f sub x and f sub y. Game, let's do it. So partial with respect to x, the first term, tanh po. So ang derivative is sec squared times derivative na nasa loob for my chain rule. Yung nasa loob, yung 2y ay constant coefficient lang, times ko siya sa derivative ng 1 over x squared na negative 2 over x cubed. Then, itong log to the base 3 naman, it's just 1 over that something ln 3. Derivative pa po no nasa loob na xy cubed. With respect to x, that's just y cubed. Okay? Times dx, of course, plus the partial with respect to y. Itong tanh sec squared pa din, pero ang derivative na ng 2y over x squared with respect to y is just 2 over x squared plus derivative nito with respect to y, so 1 over xy cubed ln 3, but this time, derivative ng xy cubed with respect to y is your 3xy squared. Times dy, of course, simplify lang natin, combine lahat ng pwedeng i-combine, yung mga pwedeng ilagay sa numerator, nilagay ko. This is what I get. Okay? Now, paano naman ginagamit itong differentials? Ito nga sinabi natin kanina na pag-approximate ng changes in your function value. Let's try to look at this example. Ito naman po yung aking function, and this time I'm specifically asked to find the change in f as xy changes from these values to 0 to these values 1.95, 0.02. And what I need to do first is find the differential of z because that's what we will use. So if we do that, yung f sub x, it's very easy. 2 to the yx, no? 2 to the y yung coefficient. Derivative ng x I want, kaya 2 to the y lang, times dx. Ito namang cosine y, wala siyang x, so bang si 0 lang yan as a constant. Derivative with respect to y, itong first term, x times derivative ng 2 to the y, that's x to 2 to the y ln 2. Tapos, itong negative cosine y will just become positive sine y times dy. Now, after this time, I have a specific values for dx and dy na. Kasi, given na sa atin kung ano yung change in x, which is from 2, gagawin nating 1.95, and yung ating change in y. So, we just plug in those changes, and we will also plug in the initial or the old values for x and y, which is 2 and 0. Okay? So, we plug in x equals 2, y equals 0, dx equals the new one minus the old one, so that's negative 0.05, and dy is 0.02, the new value, minus the old value, 0.02. And if we plug in all of those value, again, I am looking for delta f, that's the change, the exact change in f, and it's approximately equal to dz or df, which is this, no, when we plug in these values right here. Okay? Now, if we simplify this, 2 to the 0 is 1 times negative 0.05, it's negative 0.05. This term naman, 2 to the 0 is 1 times 2. That's 2 ln 2. Ang sign 0 ay 0. So 2 times 0.02, that's 0.04 ln 2. And this is my approximation. And let's see how close this approximation is, how good this approximation is. If we use a calculator, the answer that we got is negative 0.0227. But the actual change, if I plug in 1.95 and 0.02 doon sa ating function na given kanina, and if I plug in 0 and get their difference, the actual change will be this one. And why? So, ang ganda niya, it's a very good approximation. It's very close. And why is doing the differential better than getting the actual change? Because clearly, 1.95 and 0.02 are not very beautiful numbers, specifically when you use it in computations. Okay? Good. Now, let's do this next example. Dito naman, gagamitin natin yung differentials in word problems like this. So for this problem, I want to estimate the volume of the metal needed to cover a closed cylindrical tube that is 12 inches long and 2 inches in radius if the metal to be used is 0.03 inches thick. So babalutan mo ng metal yung isang cylindrical tube. So gaano kaya karami yung metal na kailangan mo? Given na yung metal is may kapal na 0.03. So, how do I measure the volume ng metal na ibabalot ko? Well, the volume of that metal is just the volume of the covered tube minus volume of the original tube. Meaning, kunin ko yung volume ng tube na may balot na metal, tapos kunin ko yung volume ng tube na walang balot. Yung difference nun, syempre, yung volume ng metal na nakabalot, di ba? And this is where differential will actually come in because ito yung i-estimate ko, yung volume ng metal na ito nga yung katumbas. Ito ay difference ng function value. Diba? So, it's really an application of your differentials. My function being the volume of a cylinder, pi r squared h, which we know to be a function of radius and height. Okay? Good. So, now, so ano yung mismong i-approximate ko? Edi yung volume ng covered tube, which is just V of 2.03, 12.06 minus V of 212. V of 2.03, 12.06, ito yung volume ng covered tube. Ibig sabihin, it's the volume of a cylinder with radius 2.03 and height 12.06. Bakit iyan yung coordinates? Kasi yung radius ng aking original cylinder ay 2, tapos binalutan ko pa siya ng metal, yung thickness nga ng metal mo, 0.03. Kaya yung radius mo, dadagdagan ng 0.03, naging 2.03. Yung height mo naman, ay naging 12.06. Kasi po, 12 inches yung haba ng cylinder, at 0.03 yung kapal ng metal in both ends. So, dalawang 0.03 ang madadagdag sa aking height. Therefore, 12.06. Of course, minus the original dimensions for the volume of the original cylinder. Okay? So, ito yung i-approximate ko, And how do we do approximation of difference in function values? We get the differential. So the differential of V is just this, partial with respect to one of your variables, say R times the change in R, plus partial with respect to H times the change in H. Game. Differentiate mo si V with respect to R, you will get 2 pi R H. And pag dinifferentiate mo naman si pi R squared H with respect to H, you get pi R squared na lang, times DH. Okay? Now, plugging in these values. So, plug in ko yung 212 sa R at H bilang yung old nasisilbing old values natin dito. And then yung DR mo, yung change in R is 0.03, change in H being 0.06, what I will get is 48 pi times 0.03. 2 pi RH becomes 48 pi because R is 2 and H is 12. no? So 24 times 2, 48 pi. Tapos yung pi r squared, r is 2. So 4 pi lang yan times yung dh ko na 0.06. If I simplify this, I get this, which is just 1.68 pi cubic inches. So that's approximately the volume of the metal I need to cover this given tube. Okay? And lastly, let's go to your local linear approximation of a function of x and y. No? Given ako ng function of x and y, given ako ng specific values a, b, yung local linear approximation or linearization at a, b is still a function of x, no? Defined this way, no? It's just the function value at ab plus the partial with respect to x at ab times x minus a tapos partial with respect to y at AB times y minus b. Ito ay function pa rin ni x at y. Yung x at y ko matatagpuan dito sa x minus a tsaka sa y minus b. Eh ano naman po yung ginagawa ni LLA? LLA is a good approximation for your function value at xy whenever xy is close to your AB na kung saan bumase yung LLA mo. Iba-iba po yung LLA kasi natin, no? Per different values of A and different values of B. So, ano yung difference niya sa differentials? Again, yung LLA, ang ina-approximate niya yung iyong function value, unlike yung differentials na ang ina-approximate is yung change in function value. Okay? Good. Let's put this to practice. Hanapin natin yung linearization ng f of xy at a point 2, negative 1. Again, ang ina-expect kong sagot is isang panibagong function ni x and y. So, yung f sub x and f sub y, purgang-purga na kayo dyan sa partial derivatives. I will leave it to you. If you want, you can pause this video first, no? Then compute for f sub x and f sub y, no? And then play it again to see if your answer is right. But i-show ko na siya ngayon. Ito siya, yung f sub x. F sub y naman ay ito. Okay? Therefore, may L of xy, no? Function value at AB, no? Tapos, f sub x at 2, ang a at b ko is to negative 1 respectively. Tapos, x minus a, x minus 2, plus f sub y at 2, negative 1 times y minus my b, which is negative 1. Okay? Yung f of 2, negative 1 is 16 tangent inverse ni negative 1, no? Pag plinugin ko kasi si 2 sa x to the 4th, I get 16. Tapos, itong loob ng tangent inverse, yung x squared y over 4, yan po ay magiging negative 1. It's 2 squared times negative 1 over 4. It's negative 1. Tapos, itong f sub x of 2, negative 1, tsaka f sub y of 2, negative 1. Plug in nyo lang si 2, negative 1 dito, no, sa mga first partials. I will leave it to you. Again, if you want to try it on your own, you can pause the video first and then play it once you're done to see if you're right. But, ako ipapakita ko na, no? Ito po yung mga function values natin. Okay? So, simplified, tangent inverse of negative 1 ay negative pi over 4. No? So, negative pi over 4 times 16, negative 4 pi. Evaluating the others, I get this linearization. Okay? Hindi naman na masyadong mahalaga i-emphasize dito yung ating computations, no? As long as you know the process. Okay? Again, this is a function of x and y, no? Even though this is a linearization at a specific value to negative 1. Now, for our last set of examples, let's try to apply LLA to approximate some values. No? Halimbawa, itong dalawang ito, which obviously are not very easy to exactly compute by hand. Ano? So, gagamit tayo ng linearization to approximate them. Dito sa first one, so, ang gagawin natin is, first, we will find a function, no, that can correspond to this value when we plug in certain values. Halimbawa, sa number 1, if I take f of xy to be x cubed y to the 5th, then this value that I'm looking for is just the function value no, at negative 1.99, negative 1.01. Pag plug-in mo to sa pinili mong x, makukuha mo to eh, di ba? Okay, so ngayon, pwede na tayong gumamit ng LLA since yung LLA talaga ay nag-approximate ng function value. So, kumbaga, ginawa nating function value itong number na ito. Okay? Good. But how do I approximate this? Well, take note that negative 1.99 and negative 1.01 is close to negative 2, negative 1. So, hanap ako ng magandang number na malapit sa kanila. And then, yung number na yon, hahanapin ko yung LLA at that number. At that values of x and y. Okay? So, yung LLA at negative 2, negative 1, no, ay magandang approximation ng function value at any x's and any y's na malapit sa kanila, sakto malapit nga itong hinahanap natin. Okay? Game. Hanapin natin yung LLA. So, kailangan ko yung function, yung f sub x tsaka f sub y, no? Madali lang naman yung derivative ng x cubed y to the fifth, no? Halimbawa, with respect to x, yung y to the fifth, coefficient lang na constant, yung x cubed, derivative, 3x squared. Ito naman sa f sub y, yung x cubed ang coefficient na constant, yung y to the fifth, pag dinifferentiate, 5y to the fourth. Okay? LLA at negative 2, negative 1 is function value at negative 2, negative 1 times f sub x of negative 2, negative 1 times x minus negative 2, hence x plus 2. Tapos yung last, f sub y doon sa negative 2, negative 1 times y plus 1. Function value at negative 2, negative 1, plug in ko dito sa x cubed y to the fifth. If I do that, I'll get negative 2 cubed times negative 1 to the fifth. That's negative 8 times negative 1, positive 8. Etong f sub x ng negative 2, negative 1, if I plug in negative 2 here, I get 4 times 3, 12. May negative 1 to the fifth ka, so negative 12 times x plus 2 plus f sub y of negative 2, negative 1, iwan ko na sa inyo, that's negative 40 times y plus 1. Okay? Now, this is what I'm looking for, no? Which is approximately the LLA at negative 1.99, negative 1.01. Okay? Again, magandang approximation lang tong LLA na to for these numbers because this is the LLA at negative 2, negative 1 na nagkataong malapit dito sa dalawang to. Okay? Hindi kahit anong LLA pwede. Game. Computing natin ito. Plug in ko si negative 1.99 sa x, si negative 1.01 sa y. If I do that, I get something like this. So I get 8. Ito magiging negative 1.99 plus 1. I get 0.01 times negative 12. Tapos ito, negative 1.01 plus 1, I get negative 0.01, tapos sinama ko yung negative na yun sa negative 40, naging plus po iyan. No? If I simplify further, I get these values equal to 8.28. No? At pag kinalculate mo itong actual value na ito, ang lapit, 8.28, 26. No? So that's how you use LLA to approximate ugly values like this. And last example natin. Wait, before we continue to our last example pala, hindi unique yung function na pwede mong piliin. Hindi lang x cubed y to the fifth. Halimbawa, pwede mong piliin negative x cubed y to the fifth. Sure, kaya lang imbis na f of negative 1.99, negative 1.01, f of 1.99 na lang. No, kasi negative x cubed na to eh. Para pag plug in ko, ito pa rin makukuha ko. No? Pwede naman ganito kung gusto mong pahirapan ng konti sarili mo. X cubed tapos y minus 2 to the fifth. Wala lang, gusto mo lang y minus 2, no? Pero this time, ipa-plug in mo naman, no? F of negative 1.99 para sa x cubed. Tapos, 0.99, no? Kasi yung 0.99 minus 2, negative 1.01. So, pag plug-in mo to dito, makukuha mo pa rin ito. And many more. Napakadami pang possible options na pwedeng piliin. Pero, ito kasi yung pinaka-intuitive and yung pinaka-madaling maisip, no? Sa unang tingin. So, ito na yung piliin natin. Okay? Last example na tayo. Approximate ko naman to. Gamit naman ako ng G para maiba. Tapos meron akong e raised to something plus something squared. E di, piliin ko e to the x plus y squared. Kung gusto mo e to the y plus x squared, pag balagtarin mo yung variable, it doesn't matter as long as magko-correspond din yung mga values mo. No? But if this is my function chosen, then this value I'm approximating is just, oops, ayan, g ito dapat, sorry. It's just g of negative 0.01, 0.98. Okay? So, gamitin ko yung LLA at 0.1. Bakit at 0.1? Kasi negative 0.01 is close to 0 and 0.98 is close to 1. So, at least, yung LLA ko magiging magandang approximation. Okay? So, ito yung kanilang partials. No? Madali lang naman yan. Hindi ko na i-detail. Game. So, function value at 0, 1, f sub x at 0, 1 times x minus 0 plus f sub y at 0, 1 times y minus 1. Because my a, b here is 0, 1 respectively. Function value at 0, 1, ito yung function ko. G to lahat, sorry. G yan lahat. Kunin ko yung function value at 0, 1. I get e to the 0 plus 1, that's e. Tapos f of x, or f sub x of 0, 1, ito yan. Same lang sila actually. So, e pa din yan, tas times x minus 0 or x. Tapos, itong f sub y of 0, 1, ito na yan, no? Yung y ko 1, yung x ko 0. So, 2 times 1 times e to the 1. So, I get 2e times y minus 1. Therefore, the value I'm looking for is approximately the LLA at negative 0.01, 0.98, which is LLA ng 0.1, no?
What?
LLA, sorry. Value ng LLA at 0.1 at the point negative 0.01, 0.98. Okay? So, malinaw ba yun? LLA, no? Based from 0.1, ipa-plug in ko dun si negative. Mali. Plug in negative 0.01 and 0.98 to the LLA at 0.1. Pwede na yun. Guess nyo na yan. Okay. So, ito yan. So, e plus e to the, or e times negative 0.01 plus 2e times negative 0.02. No? Because x here is negative 0.01, y here is 0.98 minus 1, that's negative 0.02. If you expand, ano ba tama? No? Pwede kong i-factor out yung e dito para ma-evaluate natin ng maayos. So, matitira e, tapos ito negative 0.01, tapos ito 2 times negative 0.02 or negative 0.04. Okay? Yan mangyayari kapag factor out ko si e. Tapos, itong nasa loob, ang matitira ay 0.95. Kaya 0.95e ang approximation natin for this one. You can check the actual value of this, tapos kunin mo din yung value ng 0.95e. Tingnan mo, malapit lang sila. Okay, and of course, katulad sa iba, marami kang possible values or marami kang possible functions na pwedeng piliin. G of xy pala ito, sorry. No. Dulo na lang, mali-mali pa. So, ayun. And of course, dapat mag-correspond yung mga function value na hahanapan mo ng approximation. Okay? And that is it for our discussion for today. And that's it also for my discussion videos. Thank you.